This edition is titled Upscaling Mass Rearing of Edible Grasshopper and Cricket Species for Improving Food Security in Northern Uganda. We would like to welcome Dr. Geoffrey Malinga. He's an associate professor at the Department of Biology at Gulu University. We would also like to welcome Mr. Francis Zengendo and Marta Aleroquer, both PhD students at the Department of Biology, also from Gulu University. Allow me to make first 3 practical announcements. Throughout the presentation, you can raise your questions in the chat. We will make sure to discuss them afterwards during the Q&A. During the presentation itself, please mute yourself. However, during the Q&A, you can unmute yourself, put your cameras on, and address your questions directly to the presenters. And be aware that this community talk is being recorded, so we can share it afterwards on our YouTube channel. So without further ado, let's dig in. We hope you enjoy the community talk.
And welcome everybody for this community talk on upscaling mass rearing of edible grasshopper and edible cricket species for improved food security, nutrition, and sustainable agriculture in northern Uganda. So this project is a 5-year project, and it's a collaboration between 3 universities: Thomas More University of Applied Science in Belgium, and 2 Ugandan universities, Gulu University in northern Uganda, and the Mbara University of Science and Technology in western Uganda. So in this project, we have 2 PhD students, 1 female and 1 male, Martha and Francis, who are doing different aspects in the project. Martha mainly focusing on community aspects, and Francis is focusing more on designing technologies for mass rearing. We also have several Flemish and partner co-promoters that we are working with across different universities in Uganda and also outside Uganda. So the main question here is why this project and why northern Uganda? So as a background, northern Uganda, compared to many parts of regions in Uganda, has been performing poorly in all development indicators. And it is one of the poorest regions in Uganda. But besides that, food and nutrition security is a serious issue. Mainly, this is mainly underground community where most of the communities are subsistence farmers. And it is mainly the women who are doing most of the farm labor, and usually on very small pieces of land. And women are generally marginalized, especially when it comes to ownership of land. They don't own land. Land belongs to men and not women. And as such, they normally have challenges in the production because they don't own land. Besides, this region also had 20 years of protracted armed conflict between the Lord's Resistance Army rebels and the Uganda People Defense Forces. So many people live in camps, and apart from people living in internally displaced people camps here, this region also hosts nearly 70% of refugees coming from Southern Sudan and also from Congo. And there are very huge camps, and the income and employment opportunities is extremely limited. And many communities cannot achieve self-reliance and also support their livelihoods. And as a result, there are serious social and health challenges, and there are very high levels of malnutrition have been reported, especially among children and also women of reproductive age. So there is generally unemployment, youth, and all those unemployment also lead to other challenges. Very high level of high food prices, especially for meat, which is in most cases are not affordable, and many people resort to unsustainable practices, including charcoal burning, sand mining, and the draining of wetlands, and all these activities um, lead to um, escalation of climate change. So there is therefore need to find sustainable protein-rich foods um, for the communities, not only as a source of food, but also as a source of income and employment, particularly for the youth and for the women. Edible insects, which is actually highly accepted in this part of the country, can provide a sustainable solution to these problems of malnutrition, and they are easy to rear. They can be reared on small pieces of land with very limited resources and limited investments. And this is something that can be adopted by socially marginalized people like women, youth, and the, the refugees. But the main challenge here is that currently most of the edible insects in the country are harvested from the wild, and therefore they are only seasonally available and in very high price. And by the way, the price of one of the most precious edible insects in Uganda, Rusfolia differens, which you see in the pictures here, is actually higher than the price of meat. It nearly doubles. A cup of these insects nearly doubles the price of 1 kilo of meat. And everybody runs for this. So this is a source of income, especially for women. And many women are the ones involved at different stages, including plucking. So studies in other regions have shown that insect farming can be economically viable. But in Africa, implementing this is actually has lagged behind. So, but the main bottlenecks related to this are quite many. And one question which we need to answer is, how do we mass rear this in large scale? And to mass rear this, we need low cost feeds, which is less competitive with humans and livestock. We need an optimal rearing cage. We need to understand the optimal rearing density. How do we store our eggs so that we can have eggs off season and it is readily available for farmers? And they also dealing with the communities. Are communities willing to adopt insect farming, or are they willing to consume? We need that understanding. And their skills in business and entrepreneurship. These are gaps that our project aims to address. So the aim of the project is to improve community resilience by developing efficient and sustainable technologies for mass rearing of highly nutritious and sustainable edible grasshopper Spolia differens and edible cricket species, Asceta domesticus. And also building capacity of students at Gulu University, Mara University, of science. So these are some of the intermediate results we aim to achieve, develop layering methods, improve alternative cage design diets which are suitable for communities and the households and communities. Also developing farming practices based on rare edible insects, build capacity, human and institutional capacities in edible insect production, and improve willingness of communities to adopt insect farming and to consume edible insects, and increase awareness about edible insects. So we think that successful implementation of this edible insect farming and promotion of consumption among the population in northern Uganda can employ the marginalized group, including the youth, the elderly, and women, and could also contribute to achieving many of the sustainable development goals, including eradicating poverty, reducing hunger, malnutrition, and ensuring also improve gender equality and as well as managing natural resources. So what have we done so far? So in this section, I leave to the students to in some, we have in the last years been able to collect data, and we have submitted 7 manuscripts. One is already accepted for publication, and the 6 under revision at different stages. For the purpose of this presentation and in order to manage time, we are presenting 3 different study results of 3 different studies. France to start the presentations, and please manage the time. Francis, you're welcome.
Yes, thank you, Professor Malinga, for this wonderful introduction. Once again, I'm Francis Sengendo. I'm a PhD student on this project. I started with the task of developing alternative diets for rearing these 2 species of insects, that is Ruspollia differens and Acheta domesticus. I'm going to present 2 of my papers that have come up from this work, and one is about the growth and survival and the nutritional composition of the edible longhorned grasshopper, Ruspollia differens, reared on diets from oilseed byproducts. This paper is under review in the International Journal of Tropical Insect Science. To briefly introduce, the longhorned grasshopper is a significant source of food in the South and Eastern Africa, which is very rich in nutrients. And it is a delicacy in Uganda. During the swarming season, this insect is all over the country. In most towns, you find it on the streets, people buying, and people are employed at different nodes of its value chain, including harvesting, preparing it, and selling. So it employs a lot of people, but it happens only during 2 seasons of the year, that is between April and June and October to December. Can continue. Yes, it is recently being depended on from wild harvest, but these harvests are declining due to overharvesting and destruction of its habitats. Despite the effort in identifying nutritious diets, which are less competitive, there is still a need to identify more diets that can be used to rear this insect with less competition from the food which is competed for by humans and other feeds that are used in conventional livestock. So to address or to contribute to this challenge, we tested 8 diets that were constituted from 3 oilseed byproducts, that is shea butter, sunflower cake, and oil palm seed cake. And we used the germinated millet as our control. We chose these oilseed byproducts because they are readily available from small scale oil factories and large scale oil factories, and they are still underutilized in this region of the country. You can continue. Another slide. Yes, the aim of this study was to develop diets that can be used in the rearing of this insect. So we evaluated 8 of them on their effect on survival, adult weight and development time, and the nutritional profile of this insect. The key questions that we wanted to answer are: does survival, adult weight, and development time differ among individuals fed on these different dietary treatments? And does the content of protein, crude fat, ash, and dry matter, minerals, and fatty acids differ among the insects reared on these different diets? Those are the key questions that we answered in this study. We ran this experiment as a completely randomized block design where we had 1-day-old nymphs of Rusphoria difference subjected to the 8 different treatments. These diets were as follows. We used germinated finger millet as our control. So germinated finger millet. Then the 3 diets were a combination of germinated finger millet in a 50-50 ratio. And then the other 3 diets were soy oilseed byproducts. And then we had one diet where we combined all the 3 byproducts in a ratio of 25%, and we included 25% of germinated finger millet. Can you continue? Yes, briefly, our results show that sunflower-based diets, that is 100% sunflower, and a combination of sunflower and germinated finger millet, we are comparable in terms of survival. We got the highest survival in a combination of germinated finger millet and sunflower. We also observed that oil palm seed cake supported survival of these insects. But we didn't observe any survival in all diets that had shea butter in them. And this could have been because shea butter contains some anti-nutrients that do not allow the insects to survive or to digest the feed and grow. And maybe it could also be having some deterrents that we are not able to attract the insects to feed on them. However, this will further be investigated to confirm. You can continue. Yes, in terms of development weight and adult weight and development time, we observed that the 4 diets, that were combined, germinated millet combined with oilseed, with sunflower cake and oil palm cake, were comparable to the control, which is germinated finger millet. And we also observed a shorter development time in germinated finger millet combined with the sunflower cake and also the oil palm cake. Continue. Another slide. The insects reared on germinated finger millet were richer in crude fat and carbohydrates and monosaturated fatty acids, whereas those that were fed on the oilseed byproducts, that is a combination of oil palm cake and sunflower cake, were richer in protein, minerals, and polysaturated fatty acids compared to those that were fed on soil germinated millet. Next. This is a table showing the nutritional composition of the diets and also the nutritional composition of the insects that were harvested from the different diets. And this also shows the mineral composition of the diets and the insects. I've already talked about that. This is the fatty acids. We observed that the composition of fatty acids in all the diet treatments were significantly different according to the non-metric dimensional scaling. Can continue. Yes, as a conclusion, we can say that sunflower seed cake and a combination of either sunflower or oil palm in a ratio of 50% with 50% of germinated millet can be used as an alternative to sow germinated millet to rear Lucifolia differens. And these diets can be used to enhance the protein content, the minerals, and also the polysaturated fatty acids, which are very rare in most of the food that we consume. For further studies, we need to focus on increasing the content of linoleic acid in these diets to produce Lucifolia differens that is more nutritional suitable. This is because this acid was limiting in most of these oilseed byproducts, and we think if we can find another source of this diet and incorporate it or combine it to these diets, then we can have a diet which is richer in this acid, and this can enhance the ratio of omega-3 and 6, which is very important in the nutrition of humans. Next. Yes, this is another paper about Acheta domesticus. Here we also assessed the growth performance and the nutritional value of the edible crickets, that is Acheta domesticus, reared on maize bran which was supplemented with oilseed byproducts. Briefly, Acheta domesticus is one of the major insects that have been successfully domesticated. However, domestication is challenged with expensive feed to rear this insect. So in this study, we aimed at developing an alternative feed that can supplement the commercial feed or replace the expensive commercial feed that is used in rearing this insect. We tested 5 diets, and these were also from oilseed byproducts, that is sunflower cake, chia seed cake, and oil palm cake. Can continue? Yes. This experiment was also arranged as a complete randomized and replicated block design, where we reared these insects individually and subjected them to 5 diets. These diets were a combination of each of the oilseed byproducts with maize bran in a ratio of 50 to 50, and then 25% of each of the oilseed byproducts and maize bran, and we used the commercial commercial chicken feed as our control. Continue. Our findings show that insects that were fed on a combination of maize bran and sunflower cake was high compared to the commercial chicken mash, though there were no differences observed, but we observed the least survival in those that were fed on a combination of shea butter cake and maize bran. Can continue. For adult weight, we also observed high individuals that were high weight of individuals that were fed on a combination of maize bran and sunflower cake. And this was followed by those fed on a combination of oil palm seed cake and maize bran. In terms of development time, insects that were fed on the combination of sunflower cake and maize bran were comparable to the control, which is the commercial chicken mash. And we observed a longer development time in those that were fed on a combination of shea butter cake and maize bran. The nutritional composition of Acheta domesticus based on Acheta domesticus that was fed on the control diet was rich in proteins. But those that were fed on this maize bran that supplemented with either sunflower seed cake or oil palm seed cake contained high fat, minerals, and polysaturated fatty acids. Here, most of the minerals that were observed were the ions, and iron is a rare mineral in most of the feeds we take. So this is an important nutrient that we can get in Acheta domesticus fed on these diets. This is a table showing composition of the diets that were used and the nutritional composition of the insects that were harvested from each of the diets. And also this shows the mineral composition. This is the non-metric dimensional scaling, which was used to determine the differences in the composition, and we observed significant differences among individuals that were fed on the different diets. Can continue. We can conclude that maize bran, which is supplemented with either 50% of sunflower cake or oil palm seed cake, can be used to improve survival and weight gain of Acheta domesticus, and it also shortens the development time of these insects. We can also confidently say that to modify the nutritional composition of Acheta domesticus, we can use these diets, especially for the fat, minerals, and the polysaturated fatty acids. We recommend that a combination of maize bran and 50% of either sunflower cake or oil palm seed cake can be used as an alternative in the mass production of Acheta domesticus. Thank you.
Thank you, Francis. Now let me invite Martha for the last part of the presentation. Martha, you're welcome.
Thank you, Prof, for inviting me, and thank you, everyone. Malaro K. Martha Frani, PhD fellow at University, a Macedine project beneficiary. Looking at the local knowledge, perception, and practices regarding edible insects among different ethnic groups in northern Uganda. And this manuscript is ready for submission. Insect is one of the valuable source of protein, and then particularly for developing countries like Uganda. Just like I've said, this study documents the local knowledge, the practices of edible insect consumed, their perception, and then the attitudes towards insect from the different ethnic groups within the northern region. And next. This was a cross-sectional study where we administered 600 questionnaires in 24 villages across all the 4 ethnic groups in northern Uganda. Next. Our findings, we found that 11 edible insects are consumed, and this includes Rosfolia differens, Laceta maritaria, Cariceria aguliferia, Mycoterms subhylates, Mycoterms baliscosus, Mycoterms mycaslini, Pseudocanthomas maliteris, the centum species, Gallitophos africana, and then Linceta africana. So those were the 11 different edible insect species that were consumed among the 4 different ethnic groups. Now, the insects were preferred differently among the different ethnic groups. For example, among the Luru and then the Acholi, Rosfolia differens was the most preferred edible insect among these 2 ethnic groups. Next. Whereas among the Madi and the Langi, they preferred Mycoterms subhylinus and then Mycoterms baliscosus. Now, the reason for preference was based on the taste and then the nutritional composition. So people think that some of these edible insects are more nutritious and then they taste better than the others. So those were the reasons cited for the preference. Now, we also found out that respondents had a positive opinion on edible insect consumption. In other words, they looked at edible insect as an alternative protein source, other than relying on animal on meat as an animal protein source. They also believe that edible insect is a rich source of protein. And then about 98% of respondents agreed on that. We also found that they had a good knowledge about the source. Where do they normally get these insects? We said all these insects are seasonal in nature, but when the season comes, they know where to get this insect, and also they know at which stage are these insects consumed, and also the different forms in which these different edible insects are consumed. Just a minute. I can't see the slide.
The slide
could
is
you-
actually, the slide is
Sorry?
on, but I think the problem is network. Network is
Okay.
starting to fluctuate.
Sorry for that.
Okay, no problem. I can share the presentation. If you just give me 1 minute. And can take it from there. Sorry for the disturbance.
Okay.
Slide is opening, so okay, we're almost set to go again. Can you see the presentation?
I can't see it.
The network is fluctuating. You can share from your computer. You also have a copy.
Yeah, I can see it right. I can see it now. Thank you so
You
much.
can? Okay, perfect.
Yeah, so we found that they had a good knowledge about the source where they normally get this insect during their season, the stages in which they are consumed, and then the different forms of consumption. Now, the main source of edible insects cited was the wild harvest. Normally, when the season comes, they harvest them from the wild, and sometimes they buy them from the market, and just a very small percentage get them as gift from relatives or friends. Now, all these edible insects are consumed in adult stages. So the 11 edible insects that we found that they consume are eaten in the adult stage and in different forms. For example, others are eaten as in raw form. There are those that are fried and consumed. There are those that are roasted. There are those that are eaten in paste form. And then there are also others that are made or cooked in stew and also made as in a cake form, known as the homemade cake. Next. Now, from our study, we can conclude that the edible insect has a high diversity. And this shows that entomophagy is just a practice of consuming edible insect. So entomophagy is still a dominant practice in northern Uganda. And also in our study, we managed to get a new edible insect species that is added to the database that has not been cited in any scientific literature. And also we recommend that there is need to formulate policies, or policies makers should come up with policies that promote farming and consumption of edible insect as an alternative protein source. And also there is need for integration of edible insect into the food value chain, and also to improve food security and livelihood in northern Uganda. So we realize that when policies are there in place, edible insect, it will be easier for people to even market edible insect, and as they market edible insect, their livelihood will improve. Next. At this point, I would like to invite Professor to take up from this point. Thank you so much.
Thank you, Martha. Just to conclude, apart from the work that Martha and Francis have done through surveys and laboratory experiments, Francis has also been able to write a review manuscripts on global progress in domesticating edible crickets. This review was submitted to the National Journal of Tropical Insect Science in a special issue, and it has been revised. We are hoping for this is a final decision. Then also, I have also written a review article on strides in farming edible bush cricket in East Africa. The work on edible bush cricket, I pioneered this together with Professor A. Kironen and Professor Anne Valtinen in 2015. We started together with other researchers in East Africa. So we tried to put together a rearing protocol, develop a rearing protocol, which can be used by the farmers in the field. As we now move to the field to train farmers how to rear this, we need a protocol which farmers can actually follow. This has never existed before, and it's a thing that we have brought in. Then we have several work in progress. Martha is trying to understand the willingness of farmers to adopt edible insect farming. Before we introduce the insect farming, we want to hear from the farmers, and also are they willing to consume edible insects and edible insect-based products. We are doing this especially because they are from our study, people have different preferences for different edible insects. So we need to understand this so that it guides us on which kind of insect that we introduce for farming. Then Francis is also working on the optimal cage size and rearing density. And together with Martha, they're planning to start rearing with farmers under farmer conditions. And better also, they will train farmers on business skills and entrepreneurial skills. And also, we're trying to also test optimal conditions for storing eggs during off-season. We're doing this for both Rospolia difference and for the crickets. And we're also assessing different alternative oviposition substrates for Aceta domesticus, because we want to understand some of this so that when we move into the farmers, it is easier for us. We are moving there with the low-cost diets which farmers can easily adopt, and technologies which farmers can easily adopt. So that's all from us. Thank you very much for listening to this community talk. We invite comments and questions. Thank you. Back to you, Laura.
Thank you very much for the presentation. It's nice to see, because as you mentioned in the beginning, the project is in progress. It started in 2022. It will continue till 2027. But it's nice to see that so much has already been realized on such a short time. So thank you for the presentation, all three of you. And so, yeah, we would like to open the floor for the people who attended, people who want to ask about a specific part of the presentation, people who have similar research experience to share. All questions and comments are very welcome. Voilà. If you have a question, don't hesitate to unmute yourself and to put your camera on to ask your question directly to the speakers.
Good afternoon, team. What I'm inquiring, as Francis was presenting, we see he tried to focus on what we call manufactured feeds. One of the experiences in the field, if you are bringing a new enterprise to the farmers, they usually want local available feeds. Those are the natural feeds. So entirely our research is talking about the soya, the sunflower supplement, the maize brand. I'm looking at a village, a farmer in my community whom I'm going to tell, see grasshoppers are profitable, but you can set up this maybe when you are growing maize, maybe they'll be eating on maize. So I don't know whether the research looked at that. Then I'm also looking at Martha tried to look at adaptability of insects in our community. I think if we can put the financial implications of if I start rearing grasshoppers, what do I expect in terms of returns? Thank you.
Thank you. Maybe if I can answer that, should I answer that?
Yes,
anyone can answer.
Okay, thank you. Thank you, Wakava, for your question. You were asking about the locally available feeds for rearing Ruspolia. Now, based on a previous study we did in 2020, we found that one of the locally available feeds which is suitable for rearing Ruspolia and where they do very well, they perform very well, is actually germinated finger millet and fresh maize at silking stage. Now, these are foods which are also consumed by humans. So in this study, we are trying to get low-cost feeds which is not competing with humans. And that is why we went for like the shea butter. Those are like byproducts. And the northern region is actually a leading producer of sunflower. And this is a region which is globally known for shea butter. So the waste from the byproducts from this are always just disposed, but they could be cheaply used for rearing edible insects, minimizing competition with the livestock and the human foods. Thank you. Maybe if Francis can add something, it's fine.
Yes, I think well. What I can add is that after the previous studies confirming that millet is a good or a suitable feed for the grasshoppers, as Prof has said, it is food for human. So we are coming in to see how we can reduce on how much we can feed these grasshoppers on the millet by now supplementing the millet with these local available oilseed byproducts. So by doing that, we think we shall be reducing on the cost of the cost that would be incurred in buying the millet to feed the insects and also utilizing these byproducts that are still being underutilized, yet they are readily available in northern Uganda. Thank you.
To answer the financial implication, we've also taken care of that. One of the study objectives will look at the economic feasibility of farming this edible insect. Is it really economically feasible for households to farm this edible insect? When they farm, are they able to get some profit? So there is also a study area that we are going to look at that, and that is taken care of. Thank you.
Thank you, all three of you, for answering this question. Are there more questions from the audience? If so, don't be shy to direct your questions immediately to one of the speakers or to all of them, to the three of them. I might have a little question because I see no one is raising their hands. Maybe specifically to Marta, because you mentioned that different ethnic groups have different preferences of specific species. And can you maybe share a little bit more information on that? And does it mean that there is already a long tradition of eating grasshopper and crickets? Or is it something now that has been more and more also stimulated already for food security purpose?
Thank you very much. From our results that I have shared, we found that the preferences varied among the different ethnic groups. Basically, among the Cholis, they prefer the mycotam species to Rosfolia differens. And we're also trying to, we went deeper into why they prefer the mycotams to Rosfolia differens, and the reasons they gave were the taste. For them, they feel the mycotam tastes better than the Rosfolia, and also they think the mycotam species has got more nutritional components compared to Rosfolia, and also for them, they think that the mycotams can be eaten in different forms. For instance, you can also cook them as food. You can make them as paste, which for the case of Rosfolia, you can't make it in paste form. So another reason for the preference was also they are eaten in so many different forms. So those were the variation in the consumption, in the preference of consumption of the different edible insects among the different ethnic groups. I hope I've answered that.
Yes, thank you very much.
Hello.
I see there is a question from Mr. Newton Muzinguzi. If you're still there, you can ask your question, please.
Hello, everyone. I don't know if heard clearly. I want to thank the presenters of the day and viewers for hosting us for this event. My main question is, I'm mainly interested in making research about ornithology studies about the birds, mainly in Uganda. We are having a bird species called the gray-crowned cranes. And these species, they prefer use of the crickets and the grasshoppers as their alternative sources. And in my master's research, I've been interested in identifying the food sources of these crested cranes, and they have altered to use the farming grounds, or what we can call agricultural fields, resulting into human crane conflicts. So I don't know if it would be possible making up some ideology of the study about how these crickets and different grasshopper species can be used as alternative sources of foods for the gray-crowned cranes within the wild, so that they can be used as a preventive or a control measure against the use of the agricultural fields for feeding or foraging by these species. Thank you very much.
That's maybe a question for Dr. Malinga.
Yeah, thank you for the question and for the ideas of testing whether the edible insects could be used, but used in studies of birds. But the key question which needs to be answered here is, are you planning domestication of the gray crowned crane? And if so, I do not see any reasons why this cannot be possible, because several studies have shown that edible insects can be successfully used in rearings of poultry, and they can improve the nutritional content and even improve the growth and reproduction in poultry. And I guess that this should be possible also if you plan to domesticate gray crowned crane, especially given that most of its habitats in Uganda are getting degraded. Gray crowned crane, as far as I know, they breed in wetlands, and many wetlands in the country is getting degraded because of the increasing populations. So to maintain this, to conserve these birds, maybe plan to domesticate them and rear them, and this could be something worth undertaking. Thank you.
Thank you very much for your answer and for the interesting question. Unfortunately, we're running out of time. There are two more questions. I will combine them, and this will be our last question. So one is related to environmental issues, especially in the phase of climate change. The question is, are there environmental impact assessments for these to ensure their sustainability, such as life cycle assessment? And maybe somehow related, another question is how to regulate factors like temperature and humidity to guarantee successful rearing of these insects.
Yeah, thank you, Laura. If I may answer that question, we have done several work on this. There is a work which was published by one of my students way back in 2018, 2019, where she manipulated temperatures in the lab to try to find out the optimum temperature for rearing Rospolia differens. So this work has already been done and it is published, and it is coming in our review article where we summarize the protocols for rearing of Rospolia differens. Yeah. Then there were issues of the environmental issues. I don't know whether this is specifically relating to the ingredients which are used for rearing, or it is referring to the edible insects itself. Maybe specifically I talk about the Rospolia differens. Aside from the work that we've been doing in the lab, we have also been doing surveys throughout the country to try to find out, because sometimes in some places, these edible insects have also been reported as pests. So this is something that we are trying also to document. But to understand these insects, we are currently also trying to do another study where we are trying to answer the question, where does this insect come from? So in other words, we are trying to which habitats are suitable for them in the field. So if we are to conserve them, we also need to have clear understanding of where they breed, which habitats is suitable for them. These are sustainability issues which are very important. So in that study, we are looking at the different life stages from the first instars to adults, where they are the highest density of these insects, so that we can advise the government, we can advise policymakers on which habitats should be conserved for long-term sustainability of this insect. Thank you.
Yeah, thank you very much. Thank you for both interesting questions. They were from two different people, but nice questions to end this community talk with, because we're already past the time a little bit, so it's time for us to close off this session, unfortunately. But first, allow me to thank you for attending our community talk. Thank you for your attention and your participation. We believe it's always beneficial to share experience and insights, so thank you for that. And of course, special thanks for speakers Dr. Geoffrey Malinga, for Marta Aleroquer and Francis Sengendo for this very interesting presentation and discussion. Congratulations with your accomplishments. We look forward to the continuation of your partnership and your project. And then finally, we would also like to welcome you already for the next community talk that will take place on Wednesday, December 18th. We will then talk on a project titled Voices of Change, and how Open Doors Fellowship transforms lives, with different speakers from different parts of the world, among which Benin, Ethiopia, Nigeria, Belgium, Spain. So this promises also to be a very inspiring session. Please be aware that this community talk will exceptionally start at 1 p.m. Instead of 11 a.m. Belgian time, but we very much welcome you to join for the next community talk. So stay tuned, check our websites and social media platform to stay up to date. We wish you all a lovely day and hope to see you back in December. Goodbye.
Goodbye. Thank you.
Goodbye. Thank you.